In this video, we are going to introduce the concept of sets and define the sets of real numbers. A set is any group of numbers which satisfies the definition for the set. Starting from the bottom, the natural or counting numbers, represented by this double struck in, begin from 1 and iterate or go up by 1, so the set is 1, 2, 3, 4, etc. The whole numbers, represented by the double struck W, are all of the natural numbers and the number 0. The adding of a value to a set is called a union and is shown with a union symbol, which looks like a fat U. The integers, represented by double struck Z, are all of the whole numbers and their negative counterparts. This means the set goes from negative infinity all the way down to -3, -2, -1, 0, 1, 2, 3, and then all the way back out to infinity. The rational numbers, represented by the double struck Q, are any real number which can be represented as a quotient between two integers, any finite length decimal number, or any which end in a repeating pattern will be able to be shown as a fraction, such as P over Q. The irrationals, denoted by double struck P, are any real number which cannot be represented as a quotient between two integers. Any transcendental numbers like pi and the square roots of any prime numbers like 2 are irrational. One number can belong to multiple sets. For instance, the integer 1 belongs to the natural numbers, the whole numbers, the integers, and the rationals, as well as the real numbers themselves. To understand the relationship between the sets, let's complete this diagram. Starting from the outside, real numbers is already filled in with the full box here. Inside, there are two boxes, one that has smaller subsets and one that doesn't. Because the irrationals are defined as being not rational, we're going to go ahead and put the irrationals over here and the rationals over here. Inside the rational numbers, which one is the broadest set? Which one has the most potential values? In this case, it's the integers given by double struck Z, because it has both negative and positive whole numbers. Below that is, of course, the whole numbers. And finally, the naturals or the counting numbers, depending on how you want to say it. Let's pick where each of these numbers on the right goes to practice. -100 is a whole number because it doesn't have a decimal, but it has this negative sign outside, and so it cannot go into whole numbers and is instead an integer. So we'll put this in the integer column. -8.5 can be represented by P over Q as 85 over 10, and so it goes in the rational numbers. 4 over 7 is already in a fractional form, and so is rational. Pi is the example I gave of a quintessential irrational number, and so we'll go over here. The square root of 36 is 6. Now 6 can either go in integers, whole numbers, or the naturals, because it is positive and a whole number. And so we want to assign it to the simplest set that we can, and so it will go in the naturals. 25, much the same reason. 3.333 repeating, which is what this bar stands for, is the same thing as 10 over 3, which is, as you can see, a rational number. 5.92, much the same as before, it can be represented as 592 over 100. 0 is the only number which satisfies the whole numbers, but not the natural numbers. So 0 will be the only addition to the set of whole numbers. Minus 1/2 is already in rational form. Minus the square root of 13. 13 is a prime number, so the negative of the square root of 13 will be irrational. 1.42 can be shown as a rational fraction. 1 is the first natural number. And finally, 0.0003 is itself a rational number. There are many other sets of real numbers and numbers beyond the real numbers, but for now, these sets are what is important.